Welcome back to Integrated 2. We're looking at trig, and we've been working with triangles for a bit, seeing if they were similar. We saw the side splitter theorem. We just recently covered Pythagorean theorem, which helps us ensure that these right triangles have sides that are all going to work in a certain fashion. We're looking at trig, which allows us to describe some of the angles and some of the sides for right triangles in particular. These three functions get introduced with sine, cosine, and tangent. You'll see down here that there's a certain fraction that gets introduced when we use this sine function of the opposite over the hypotenuse. So notice the first letter of O divides by the first letter of hypotenuse H. So this so, ka, to, I think I've probably heard it in the past, but now you're actually going to apply it. So I think of this as, imagine you're standing in some triangle on the beach, you're posted up in this corner, and you're trying to admire whatever side is in the distance. You can consider that to be your opposite. The hypotenuse, luckily, is always going to be the hypotenuse, and whatever side you didn't just talk about, interestingly enough, is going to be the adjacent. So as we work through this, we may switch up where the angle is, but I imagine you to imagine you're standing in whatever corner. Think about what's opposite of you. What's the hypotenuse? That's probably the easiest one to narrow down. And don't be afraid to sketch out the vision of what's exactly opposite of you. That'll help you as you work through these. I'll work through this left side, and I may give you a moment to try the right side as I pause the video towards the end of this first bit. So I'm imagining I'm in angle A. So I'm posted up here. Opposite of me. What's the side opposite of me? 27. Nice. And my adjacent would be the 36. Recall that with cosine, this is the ka ordeal. So this is allowing us to say that cosine of angle A should be our adjacent over the hypotenuse. And what's the hypotenuse? Hopefully you said 45. So we're allowed to summarize this and say that for whatever measurement of angle A, when we apply that in cosine, that should be equivalent to 36 over 45. And you may want to flex your fraction skills of simplifying. I kind of like leaving it like this for the time being because it's paying respect to the sides that were given. But I guess while we're here, how would you simplify this? Maybe you say that it's going to be 4 over 5 because these are both divisible by 9. So something like that is definitely a problem you'll see quite a bit of. Notice I sketched out where I was. I sketched out what was opposite, what was adjacent. That's one down. Sine of z, not too bad. Again, draw wherever you're working from. Opposite of you is 18. 30 is your hypotenuse. Call that's opposite over hypotenuse. So this is a pretty simple, just 18 over 30. Moving along. I know I could have simplified that, but I'll leave that to you. Cosine of x. Recall this is our adjacent over our hypotenuse. So this will be a simple 8 over 17. Again, I didn't draw it here, but don't be afraid to sketch out where you are so you can make a note of what's adjacent, what's opposite of you. Tangents, luckily the one that doesn't need the hypotenuse, because recall, it's the TOA, which was on the very first page we looked at. So imagine you're here, opposite of you is 24, adjacent's 18. So our tangent of x is going to be 24 over 18. Take a moment, try these 4. The video will pause so you can give these 4 on the right side a shot. Take a moment to try that out. Hopefully you got these accordingly. I circled the most simplified form of the fraction, but if you got these, give yourself 4 out of 5 stars for those. But I think if you got everything that's circled, those are all pretty solid 5 stars. Nothing wrong with the 4-star answer, but a nice chance to flex some fraction simplifying if you got the circled portion. Cool. Down here, as I expand this whole window, you're asked to evaluate these with your calculator to the nearest 10,000th, and I will do just that because luckily I have this little tool. So one thing I would make a note of is that your calculator should be in degrees when you do this. So double check if you have a newer calculator that up here it says degree. If it says something else, follow these steps, which you can follow with the buttons that are here. Let me clear this all out. So we're ensuring that we're in degrees. You can get that to happen by hitting not math. We're hitting mode. We're going down to the radian degree, and the goal is to have degree highlighted. So make sure that happens before you do these few problems. So this first one was sine of 21. We're hitting sine. We're hitting 21. We see that's 0.3584. We then have cosine of 20. Cosine 20. This really just gets you familiar with where these buttons are on your calculator. This isn't like brain surgery doing these, or at least it shouldn't feel that way. Tangent of 17, sorry. Tan 17. And you see all of these answers are decimals, which is fine. They're all rounded to the fourth. I guess if you're curious how I did that, you can do mode, and instead of float, you can just have it go to the fourth so that you have 4 decimals show up. Fun little calculator trick. I hope this was helpful. We'll use Trig a decent amount this year, and you'll see a lot of it if you end up in pre-calc, which if that's your end goal, this will definitely come back. So thanks for watching. We'll talk soon.